Hey everyone, welcome back to the channel. Today we're diving deep into the world of blockchain technology. Whether you're a beginner or someone looking to brush up on your knowledge, this video has something for everyone. We'll cover everything from the basics of blockchain and cryptocurrency to advanced topics like Merkle Trees, proof of work, and even how to create your own smart contract. So grab a coffee, sit back, and let's get started. Let's start with the basics. What is blockchain? At its core, a blockchain is a decentralized, distributed ledger that records transactions across a network of computers. Each block in the chain contains a list of transactions, and once a block is added, it's nearly impossible to alter. This makes blockchain secure and transparent. Think of it like a digital ledger that's maintained by thousands of computers worldwide, rather than a single central authority. This decentralization is what makes blockchain so powerful. Now, you've probably heard of cryptocurrencies like Bitcoin and Ethereum. These are digital currencies that use blockchain technology to record transactions. Cryptocurrencies are decentralized, meaning they're not controlled by any government or financial institution. Bitcoin was the first cryptocurrency, created by an anonymous person or group known as Satoshi Nakamoto. Since then, thousands of cryptocurrencies have emerged, each with its own unique features. One of the key concepts in blockchain is consensus. Consensus mechanisms are protocols that ensure all nodes in the network agree on the state of the blockchain. The most common consensus mechanism is proof of work, which we'll dive into later. Now let's talk about how you can use blockchain.com, one of the most popular platforms for managing your cryptocurrency. You can create a wallet, send and receive Bitcoin, and even explore the blockchain to see transactions in real time. It's a great tool for beginners and experts alike. If you're new to crypto, I highly recommend checking it out. Next up, let's talk about Merkle Trees. A Merkle tree is a data structure used in blockchain to efficiently and securely verify the contents of a block. Each leaf node represents a transaction, and the root of the tree is a hash that summarizes all the transactions in the block. This is crucial for ensuring the integrity of the blockchain. If even a single transaction is altered, the entire Merkle tree would change, making it easy to detect tampering. Ever wondered where it all began? The Genesis block is the very first block in a blockchain. For Bitcoin, this block was mined by Satoshi Nakamoto in 2009. You can actually search for the Genesis block using a blockchain explorer. It's a fascinating piece of history and a great way to understand the origins of blockchain technology. Let's take a closer look at the header of a block. The block header contains several key pieces of information, including the previous block's hash, the Merkle root, the timestamp, the nonce, and the difficulty target. These elements are crucial for maintaining the integrity and security of the blockchain. Proof of work is the consensus mechanism used by Bitcoin and many other cryptocurrencies. Miners compete to solve a complex mathematical puzzle, and the first one to solve it gets to add a new block to the blockchain and is rewarded with cryptocurrency. This process is resource-intensive, but ensures that the network remains secure and decentralized. The nonce is a number that miners change repeatedly to try and solve the proof-of-work puzzle. It's a critical part of the mining process, as it's the only part of the block header that can be altered. Think of it as a number used once that helps miners find the correct hash. The difficulty of a block is a measure of how hard it is to find a new block. This difficulty adjusts periodically to ensure that blocks are added to the blockchain at a consistent rate, regardless of how much computational power is on the network. This is why mining can sometimes be easy and sometimes incredibly hard. Solving the proof-of-work puzzle involves finding a hash that meets the network's difficulty target. This requires a lot of computational power and is why mining is so resource-intensive. But once the puzzle is solved, the miner is rewarded, and the block is added to the blockchain. Before transactions are added to a block, they sit in something called the mempool. This is essentially a waiting area where transactions are stored until they're picked up by miners. The mempool can get crowded, which is why transaction fees can vary depending on network congestion. Miners are rewarded with newly minted cryptocurrency for adding a new block to the blockchain. You can check these rewards using a blockchain explorer. It's a great way to see how miners are incentivized to keep the network secure. Transaction fees are paid by users to incentivize miners to include their transactions in the next block. These fees can vary depending on network congestion and the urgency of the transaction. Higher fees usually mean faster confirmation times. Blockchain technology isn't just for cryptocurrencies. It's being used in finance, supply chain management, healthcare, and even online bidding. The transparency and security of blockchain make it ideal for a wide range of applications. The possibilities are endless, and we're just scratching the surface. Now, let's talk about Ethereum. Unlike Bitcoin, Ethereum is more than just a cryptocurrency. It's a platform for decentralized applications and smart contracts. You can explore the Ethereum blockchain using etherscan.io. It's a powerful tool for developers and users alike. In Ethereum, every operation costs gas, which is paid in GUI. Gas prices can fluctuate based on network demand, so it's important to keep an eye on them when sending transactions. Think of gas as the fuel that powers the Ethereum network. Gas limits are used to prevent infinite loops in smart contracts. By setting a gas limit, you ensure that a contract can't run indefinitely, which could otherwise drain your funds. It's a crucial safety feature for developers. The Ethereum Mainnet is the live production blockchain where real transactions take place. It's where all the action happens, from DeFi to NFTs. If you're building or using dApps, this is where you'll deploy them. Finally, let's create a simple smart contract using Remix IDE. Remix is a powerful browser-based tool for writing, testing, and deploying smart contracts. Here's a basic example of a smart contract. Once you've written your contract, you can compile and deploy it directly from Remix. It's a great way to get started with Ethereum development. And that's a wrap. We've covered a lot today, from the basics of blockchain to creating your own smart contract. If you found this video helpful, don't forget to give it a thumbs up and subscribe to the channel for more content like this. Thanks for watching, and I'll see you in the next video.